You know that feeling when your computer just snaps? When everything feels instant? Well, that's not just your processor working hard. It's the magic of an unsung hero called PCIe. Today, we're pulling back the curtain on this digital superhighway, the invisible force that makes modern computing feel so incredibly fast. Let's dive in. The secret sauce behind all of that is a technology called PCI Express, or PCIe for short. You can think of it as the critical link, the digital superhighway that connects all the most powerful parts of your computer. It's the thing that lets your brainy processor, your powerful graphics card, and your lightning-fast storage all talk to each other at just mind-boggling speeds. Now, you might be thinking this sounds super complicated, and you're not wrong. The official spec for this is literally over 1,000 pages long. But don't worry, the core ideas are actually surprisingly elegant. We've waded through all the technical details for you to pull out what really matters. So consider this your express lane to understanding how this whole incredible system works. So how do we even begin to wrap our heads around something like this? Well, let's use a simple analogy. For the next few minutes, I want you to forget about wires and circuits. Instead, let's imagine PCIe as this hyper-efficient, futuristic postal service that's running deep inside your machine. So what is it, really? The official definition calls it a point-to-point serial interconnect. Okay, that sounds a bit dry. But in our postal service analogy, all that means is it's not just one big, slow road that everyone has to share. No way. Instead, it's a whole network of private, direct superhighways between any 2 points. This setup is crucial because it ensures your data gets exactly where it's going with zero traffic jams. All right, so every good postal service needs buildings and addresses, right? It needs infrastructure. And in the world of PCI, there are 3 main players, 3 key components that make up this entire network. So let's meet the family. First up, we've got the root complex. This is the big one. It's the central hub, the main post office that's directly wired into the computer's CPU and memory. Every single piece of data, every package that gets sent, starts its journey right here. It's literally the root of the whole system. Next up is the switch. And this is where things get really smart. If the root complex is the main post office, think of the switch as a super sophisticated regional sorting center. It's a collection of virtual bridges that intelligently routes all the data packages. This allows, for example, your storage drive to talk directly to your graphics card without having to bother the CPU. It's incredibly efficient. And finally, we have the endpoint. This is the destination address on the mail route. It's your home or your office. Inside your computer, an endpoint is the actual device you care about. Your GPU that's rendering games, your super fast NVMe storage, or your network card pulling down data. It's where the packages are sent from and, ultimately, where they need to be delivered. Okay, let's put it all together real quick. You have the root complex, the main post office hooked up to the CPU. You have switches that act as these brilliant sorting centers. And you have the endpoints, the final destinations like your graphics card. This simple 3-part structure is the absolute key to PCIe's organized and crazy efficient flow of data. Now that we've got the map of our postal network down, what about the packages themselves? What does the data actually look like when it's flying across these digital superhighways? Well, in the PCI world, all data is sent in these perfectly standardized boxes called transaction layer packets, or TLPs. And just like a real package you'd get from Amazon, a TLP has 2 main parts. You've got the payload, which is the actual stuff, the data you're sending, and you've got the header, which is basically the shipping label, complete with the sender's address, the destination, and all the handling instructions. So how does one of these digital packages even get built? It's a pretty logical process. First, the system creates that all-important header, the digital shipping label. Then it attaches the actual data, the payload. And finally, for some extra insurance, it can add an optional digest, which is basically a clever bit of math that guarantees the package shows up perfectly intact without a single bit out of place. Okay, we've built our package. It's all boxed up and ready to go. So now let's follow it on its journey. See, the trip from sender to receiver isn't just one simple step. It actually goes through 3 distinct logistical layers, and each one has a very specific job to do. The journey kicks off in the transaction layer. You can think of that as the mailroom where the package gets assembled and addressed. From there, it's handed off to the data link layer. This is like a high-tech tracking department that slaps on sequence numbers to make sure nothing gets lost. And finally, the physical layer acts as the mail truck and the highway itself, turning that digital package into electrical signals and blasting it across the physical wires. Now, this data link layer, It's really the unsung hero of the whole system. Its one and only obsession is reliability. It doesn't just spot errors, it actively fixes them. If a packet gets even slightly corrupted, maybe by a tiny bit of electrical noise, this layer catches it instantly, says nope, not good enough, and requests a resend from a temporary buffer. This is why PCIe is so rock solid. It's a system that guarantees perfect delivery every single time. Okay, reliability is awesome. Check. But what about the speed? We keep talking about this ludicrous speed. PCIe has gotten ridiculously faster over the years, and a huge part of that comes down to one really clever engineering secret that makes the whole thing just incredibly efficient. Here it is. This is the secret sauce. The older versions of PCIe used a system where for every 8 bits of your actual data, 10 bits had to be sent across the wire. Now, that's a 20% overhead. That's like sending out a delivery truck that's 1/5 empty every single time. It's just wasteful. But look at the new system. For every 128 bits of data, only 2 extra bits are needed for coordination. The overhead just plummets to about 1.5%. By packing that truck way more efficiently, you get a massive boost in real-world speed. So just how fast are we talking? Well, the PCIe 5.0 standard can hit 32 gigatransfers per second. That's 32 times billion transactions happening every single second on just a single data lane. It's an almost incomprehensible amount of data, all managed perfectly by this elegant system. But you know what? It's not just about the raw, blistering speed. PCI is also incredibly smart. It has sophisticated power management that lets parts of your system go to sleep to save your battery. It supports hot plugging, so you can add or remove some devices without a full reboot. It can even prioritize data with something called quality of service, making sure your video stream stays perfectly smooth, even while a massive file downloads in the background. It's the whole package. So at the end of the day, when you think about PCI, don't just think of it as a simple connection or a wire. It's a complete logistics network. It's intelligent, it's self-correcting, and it's just astonishingly fast. It is truly the foundational layer that allows everything from high-end gaming to massive scientific research to happen at the pace that we all now expect. And that brings us to the final thought I want to leave you with. The demand for more data, faster data, is just relentless. As we push into a future dominated by AI, virtual reality, and data sets bigger than we can even imagine, the pressure on this digital superhighway is only going to grow. And it leaves us with a really fascinating question. What comes next? What does the road ahead look like when today's superhighway becomes tomorrow's quiet country lane?